Okay, in previous video, we just look at a very high level or abstract level what are geometric transformations. Here in this video, I'm just giving you an example of scaling, how scaling or image resizing can be done in OpenCV. And just to give you a motivation, how different kind of effects we can achieve. And later on we will see the algorithms or actually how that happens, and we will be writing the same kind of algorithm without OpenCV, just in NumPy. But let's just first get a look and feel of how that is done. So in this video I will give you an example of scaling in OpenCV. So let's see. I have imported NumPy, Matplotlib. Matplotlib is sometimes handy to display an image inside the notebook, although you can display the image using OpenCV as well, but it sometimes seems handy to display the image using Matplotlib. So let's import the packages, and these are two images on my computer. We have also seen we have also seen these images a lot many times in our previous module. One of the image is the grayscale image from Einstein, and the other image is tulips, which is RGB image or a colored image. These are the paths of these images. Let's read these images and call, let's say, I gray as cv2.imread gray image. And if you remember from our previous module, if we want to read the grayscale image, we have to set the cv2.imread grayscale. So yeah, so that's the grayscale image. We read the grayscale image, and then we read this colored image. And if you remember, in OpenCV, the colored image is read in BGR order rather than RGB order. So we have discussed that at length in our previous module. So let's read the colored image, imread color image, and we need not to set any flag here. So that's it. The two images have been read. Let me show each image one by one using Matplotlib. So plt.imshow I gray and cmap as gray. That's our grayscale image. And now let me show the BGR image. And if you remember, the PLT or the Matplotlib takes RGB and OpenCV read as BGR, so we have to reorder the channels. So plt.imshow I BGR. Let me reorder the channels, and that's it. So that's the image of tulips that we have read now. Let's resize the image, both grayscale and these BGR images, using OpenCV. So what I will do is I will try to let's first focus on this grayscale image, and what I will do is I will make the width of this image double and make the height of this image as 1/2. So for example, I want to stretch this image horizontally and I want to compress this image vertically. So what will happen? Let's see. So I gray resized as cv2.resize. That's a function. Resize is a function for scaling in OpenCV, and I have to give the source image as I gray. I have to give the width. I want the width to become double, and let's say I want height to become 1/2. And here is another parameter, desize. Right now I'm setting that as none. So that's my grayscale image with width double than earlier, height half than earlier, and let's see how it looks like. So now if I first display the image, plt.imshow I gray resized, and CMap as gray, plt.xsticks. Let me set these to empty so that the numbers appear in the X and Y, they just disappear. We do not need those numbers. So now you can see the image has been stretched. Horizontally it is stretched and vertically it is halved. If you really want to check that exactly it becomes double and half, we can see the shape of this. So im gray, scale im gray, resized dot shape. That shape is 474, and so the height is 474 and the width is 1456. In contrast, if you see the shape of I gray, so you might notice that in the direction of height, actually the height becomes half. Obviously this 0.5 is round off, and in the direction of width it becomes double. Not only half and double, we can change these numbers. For example, we want the height to go 1.5, and let's say we want the width to go, let's say 0.8. Then we may get a different kind of image. And the same can be done with colored images as well. So let me show you how can we do that with color image. Exactly the same way we can do with the color image. So I bgr resized equals to cv2.resize, and src is I bgr fx. Let's say we want the height to, let's say we want the width to squeeze, and let's say we want the height to actually increase. Let's say we want the height to go double, and that's our image resized. Let's display this image, plt.imshow. Remember, we have to reverse the channels if we are displaying this using Matplotlib. So now you can see it actually become thin and tall, and you can play with these parameters. That was just a snapshot of how what can you do with just with scaling. Later on, actually we will see not only scaling, we will apply rotation, scaling, shears. We will define all these. We will define the algorithms, how this OpenCV is working at the back end, and we will achieve very cool kind of effects in Python, and we will be understanding how it is happening. So not just Python, you will be understanding the algorithm of how it is happening. So yeah, let's dive in and see. Let's start with scaling and understand how the scaling is happening under the hood in OpenCV. And let's try to code. Let's first try to understand what is happening, how it is happening, and then we will code that in plain NumPy, and we will achieve the result exactly like the OpenCV. And then we will do the same stuff one by one with all other kind of transformations. So let's dive in.